So the current is basically doing this, right? It's an AC supply. So you first have to come up with an equation for the current. So the equation is I equals to I naught sine omega t. Where did I get my I naught from? I did V equals to IR, and I found that the maximum current is 0.02. Also, omega is the 2 pi f, right? So I got that. Now the question was to find the current at 0.08 seconds, right? So what I'll do is at 0.08 seconds, I'll just use this. I equals to 0.02 sine 2 pi 50 into 0.08. And yeah, once you put that in your calculator, what everyone told me it's 0. It should be 0 if it's in radian mode. Okay, let's start asking Kishore. We'll finish this chapter. Okay, so your class is till 5:30, or until the chapter finishes. Okay, so maybe 5:30 longer with the part. So it's the power calculation problem. So it again fixed. Last class start course, but I don't think I gave enough time on it, so I'm going to start for it. So what is this power calculation problem they here do? Right. So power calculation problem comes from the concept that let's say you have an AC supply here, and you connect your AC supply to a bulb or any appliance out there. I'll use bulb for reference. It's easy to understand. It's like a bulb connect my AC supply, and this is AC supply. So AC supply লেখার জন্য হচ্ছে কিছু criteria আছে. Whenever you draw the supply, what do you need to mention with it? Whenever you write an AC supply, you need to provide the peak voltage. Peak voltage মানে হচ্ছে সবচেয়ে highest voltage কি হবে? V peak. And also you need to provide the watt of the supply frequency. Okay, so এখানে 50 hertz or something. Right, so that's what we know right now. And this is a lamp going here, and somebody comes and asks you, what is the power dissipated by the lamp? What does that mean? They put the power bear. And what's the formula for power that we know? P equals to VI. We also know that there's another equation, which is what? I square R. There's also another equation, which is what? V square by R. And I want to use these, right? But there's a problem here. Problem to Kiboli. If you look at the voltage and current, right? Both of them have this graph. And it's supposed to be like that because it's an AC supply, right? কেউ কি আমাকে একটু ফরম্যাটটা রিমাইন্ডার দিবে AC সাপ্লাইয়ের ইকুয়েশনটা কি রকম দেখতে হয়? The V is equal to, basically tell me what the equation is supposed to be for the graph on the top. V equals to V naught sine omega t. So my voltage is fluctuated. Voltage টা বারবার চেঞ্জ হচ্ছে। তো আমি যদি এই ইকুয়েশনটা ইউজ করি, right? I have to use some voltage here or there. Which voltage do I use? Because if you look at the graph, it's changing, right? So আমাকে তো কোনো একটা particular value use করতে হবে. So which value do I use here? There's 0 here, there's all the values here, there's the maximum out there. So let's say we use maximum value. So using V naught, what should my power value be here? So the power value here is going to be P equals to V naught I naught, okay, or I naught square R, or V naught square by R. These are the values for my power, right? I have a question for you, okay? Do you think that these are justifiable? Are these values the power output of your lamp? If so, why? And if not, why? So I mean, power বের করতে যাচ্ছি, আমার power formula হচ্ছে এগুলা VI I square R V square by R. And আমি কি করলাম? আমি হচ্ছে গ্রাফ থেকে দেখলাম যে maximum value টা তো আমি জানি, maximum value is same, right? সব জায়গায়. So I'll use the maximum value and find my power. So I found my maximum value for voltage, maximum value for current, maximum value for current, maximum value for voltage. And it does give me a power, right? Question also, do you think this is the right power output? Or do you think this is not the right power output? And you have to give me reason why. So do you think that if I want to find the power output of this lamp, it is ideal to use the maximum value and find it, or this is not the right way? Achha, why do you think taking the maximum is not the right thing here? Right, that's the simple answer. Because if I take the maximum value, you know what I'm assuming? That my voltage is throughout the process, how much? That. Doesn't that mean that all those amounts that I have assumed are being overestimated? Because I think it's nine, right? Also, do you see the value keeps decreasing like that, right? So the problem is that if we use this, this power is not appropriate, okay? So power not correct, since it's an overestimation or underestimation? Overestimation. It's an overestimation. Right, so power is not correct since it's an overestimation. So the question then arises, how do I find the actual power here? So some students will go for the other version. I'm সবগুলো তোমাদের সাথে discuss করব এখন. So peakটা কাজ করে না, okay? So this version that I've using here is using what value? Peak value. So peak value they করলে it is an overestimation, okay? Overestimation. So that is incorrect. What else can you do? What's an alternate way out there? So some students will go for average. The average would be better because it's fluctuating, right? So if I take average here, a graph average that you now, like, you know, if you take an average of all the points here, all the points there, like that, right? What is the average going to be? Zero, right? Because you have values all the way there, and you have values all the way here. They're all equal and they're all opposite, plus and minus, right? So I'm using the average break করতে যাই, right? Let's find the power using average. তাহলে যেটা problem হবে, it's even more unrealistic. Why? Using the average, my power output is going to be how much? Zero, which doesn't really make sense because I know my lamp is glowing. So something is not right. কারণ আমার তো lamp glow করতেছে, power can zero দিচ্ছে. That's when we realize that what equations we are using are not appropriate here. কেন? Because average টা দিয়েও হচ্ছে না, zero দেখাচ্ছে। আবার তুমি যদি হচ্ছে v maximum নাও তাহলে overestimation হয়ে যাচ্ছে। We need what here? A middle ground, right? কারণ আমার হচ্ছে যদি v max নেই, I get way too much power than what it should be. আমি যদি average নেই, আমাকে কি দেয়? Zero দেয়। But isn't the power somewhere in between? How do we get that? So এটা করার জন্য we have to come up with something. So এটা একটু advanced math. Thankfully তোমাদের syllabus এ দেয় নাই। There's derivation online if you just search it about power, but I don't want to complicate things. ওইটা হচ্ছে what is the average of a sine function? That's the math. Okay, so the math is that if you have a sine function and the values are all fluctuating, right? How do you find the average? Now there are two kinds of average. One is the average that you know, it's called mean. What do? You add all the values and you divide with a number of values. ওইটা for a sine curve is what? Zero. But এখানে একটা জিনিস বুঝতে হবে, this is positive, this is negative. Negative মানে না কিন্তু that the value is going away. Negative only means that the value is which way? The other direction in the AC supply, right? So basically ওরা যেটা চাচ্ছে or যেটা তোমাদের বের করতে হবে, what is the average of this graph? Because আমার হচ্ছে এটার average দরকার. Do you get my point? So if this was, let's say this was a triangle like this, এটার average বের করা easy হবে, মাঝখানে যাবে। Okay, because এই পার্টটার সাথে ব্যালেন্স হয়ে যাচ্ছে, এই পার্টটার সাথে ব্যালেন্স হয়ে যাচ্ছে, so you can take an average and you actually apply this in your O levels. Remember, if you wanted to find average speed for an object and the object was accelerating uniformly, তাহলে average speed কিন্তু actual average আসতো। But একটা object যদি হচ্ছে non-uniform acceleration করতেছে, the average is not really working. Cannot, because the graph is not a straight line, right? It's a curve. So the point is, how do you find the average of this? You have been doing math for some time, right? অনেক বছর ধরে করতেছো। So তোমরা আমাকে একটু বলো যে এটার অ্যাভারেজটা কি হবে, এই লাইনটার অ্যাভারেজ কেমনে বের করব আমি? RMS RMS এর জন্য নেগেটিভ লাগবে। আচ্ছা দাঁড়াও নিয়ে আসি। But yeah, how do you find average here? What are the different averages out there? Mean, median, mode, right? Arc. What else? Yeah, so we have gone through it. So it's good that Cambridge actually kept it in two topics. So there's another way of finding an average. It's called the RMS value. And this RMS value, আমরা last কোথায় দেখে আসছি? No, ideal gases, to find the average speed of all the gas particles out there, right? So RMS value কেন হচ্ছে appropriate here? Because we are trying to find average, but we want to ignore the what of the value, sign. Can I just sign include করে, what do I get? A 0, right? So I want to find the average, but I don't want the sign to be a bother here. Then, some students will just go like this, ignore the sign, right? It doesn't work that way, math, okay? So RMS helps us do that, because যখন আমি RMS use করি, first আমরা কি করি? Square, তারপর আমরা কি করি? Mean, তারপর আমরা কি করি? Root. And this will give you the true average here. And এখানে, if I take this graph, and if I plot the graph and I get the VRMS, right? ওইটা হচ্ছে is going to be my true average. It's a line that's somewhere here. The value is, if you're interested in the number, 70.7%. Okay, it's okay, so it's 1 by root 2 value there. Because what do you think actual average is of something? 50%, right? But a curve turns out there are more values in the higher part of the graph than the lower part. So the average is slightly higher. And turns out the average is VRMS যদি বের করতে চাও, there's a formula. It is your peak value divided by root 2. Now, root 2 can show you the math part that I don't want to get into. So there's a way of doing this. But the idea is that if you want to find the average of a sine function, it is the highest value divided by what? Root 2. And this is called VRMS. Now, VRMS is monetary. What does it mean? Let me explain. So V naught divided by root 2. So VRMS is too tricky, I said to carefully show. So VRMS basically means that you have converted your alternating graph into a what line? Straight line, right? And that's a what supply? DC supply. What you have done actually here by doing this math is that you have converted your AC supply to an equivalent DC supply. That's the term they use, okay? What does it mean by equivalent DC supply? মানে হচ্ছে এই AC সাপ্লাইটা তোমার অ্যাপ্লায়েন্স কে যা পাওয়ার দিবে, এই DC সাপ্লাইটা ওই অ্যাপ্লায়েন্স কে কি পাওয়ার দিবে? Exactly same. So if I take my lamp right now, remember we started with the lamp. If I replace this lamp with a, let's say, battery here, our battery voltage jodi hoy V peak by root 2, you'll find this lamp is performing exactly the same way as it was with the AC supply. It's basically converting an AC supply to a DC supply. This is what we do by this process. It's called VRMS. And etar advantage ta ki? DC supply jodi convert korte paro, DC supply formula sob amra jani. V goes to IR, the power formula, whatever you know from electricity from all levels, right? Now, instead of solving an AC circuit, you can just solve a what circuit? A DC circuit, and the outcome will be same. Why? Because you have converted the AC to a DC supply. Okay, so this is called VRMS, and that's formula. So VRMS, the conversion is basically your peak value, V peak, divided by root 2. So কোথায় লাগে এটা একটু এক্সপ্লেইন করি তোমাদেরকে। So most common use of this তোমাদের syllabus I would say 9 out of 10 times is to find the power of a lamp. তুমি একটা ল্যাম্পের পাওয়ার বের করতে চাও, তোমার কি লাগবে? ভোল্টেজ লাগবে, কারেন্ট লাগবে। কোন ভোল্টেজ ইউজ করব আমরা? The RMS. আচ্ছা, কোন কারেন্ট ইউজ করব? RMS as well, okay? But আর কোথায় এটা কাজে দেয়? So if you remember, there was an equation we learned previously, F equals to BI L sin theta. Can anyone remind me what was this? F equals to BI sin theta. Right, very good. It's the motor effect. It's the force experienced by a conductor in a magnetic field, right? এখন তোমাদের সিলেবাসে কি করে AC চ্যাপ্টারটা একটু I would say inconvenient. They will take the AC supply and stick it into every place in your syllabus এখানে কি আসতে পারে? Current. So imagine any place you have heard of current, right? They'll replace that current with a what current? AC current. তখন তোমাদের figure out করতে হবে how do you approach this. So the question that comes, right, is that you have a magnet, you have a wire, আর wire ভিতর দিয়ে DC current যাচ্ছে, তার জন্য FBI use করে you can find the force. But then they said that this is replaced, the wire is replaced with a wire carrying AC current. So first question যেটা জিজ্ঞেস করে, which way does a wire move with an AC current? Yeah, it's trying to go up and down, so it's going to fluctuate like that, because force change হচ্ছে। তারপর জিজ্ঞেস করে, what is the force? What is the force? Same as the half. না, সো আমার যদি এইটাই প্রবলেমটা। আচ্ছা, সো আমার যদি হচ্ছে ম্যাগনেট থেকে যদি তারটা থাকে এখানে, এই তারটা মুভ করতেছে বিকজ অফ এন AC সাপ্লাই, রাইট? এন্ড ইফ আই সি দি ফোর্স ইট এক্সপেরিয়েন্সেস, আমার থেকে কারেন্ট দিয়ে ম্যাপ করতে হবে, রাইট? কি ফোর্স, মানে which current do I use? Do I use AC current যাচ্ছে, by the way? Do I use the peak value? Do I use the average value? Do I use the mod value? What do I do? Right, so the answer is not RMS. Okay, so এটা যদি ম্যাথ করতে হয়, you're gonna do F equals to B I peak L sin theta. কেন? Because when the wire is moving, it is up and down move হচ্ছে, একটা পয়েন্টে wouldn't the peak current be acting on it? Because it's actually fluctuating like that. So যখন peak currentটা কাজ করবে, what will be the force acting on it? The maximum force out there. এখানে RMS ইউজ করতে পারবে না। এই অ্যাভারেজ ফোর্স বলে কি থাকবে? এটা তো উপর নিচে যাচ্ছে। তোমাকে কোয়েশ্চেনটা বলছে what is the force you experience? Wouldn't you experience the highest force it gives you? কারণ এটা চেঞ্জ হচ্ছে। So highest force এর জন্য which value would you use? Peak value. Okay, so এটা হচ্ছে as problems come by we'll have to decide. So এখানে কমপ্লিকেসিটা আসে। Okay, they'll add like a AC current into some random scenario that you are not aware of. Okay, but তার আগে আমরা আমাদের বেসিকটা আগে সেট করি, মানে at least 9 out of 10 questions এটাই হবে, that whenever you're provided with an AC supply and you want to find power, what you need to do is you need to convert your peak value into RMS value and then find power. So then if I do want to actually find power now, দেখো power কি হয়? So power output, it has its own formula. It should be what? V কোনটার V জানি, এই যে voltage AC times current AC, but আমরা তো AC তে ম্যাথ করতে পারবো না, so we'll have to convert our AC to what value? DC, right? And DC conversion to key peak divided by √2. So this is going to be what? V peak divided by √2, and ওটা কি হবে? I peak divided by √2. Can you tell me what this is going to be? V peak into I peak divided by 2. And it turns out this is what people who do electrical engineering use. So when you have an AC supply and you want to know how much power the supply is giving, you use the peak values, right? Find the power using the peak values and take what of it? Half of it. Okay, so yeah, this is like some syllabus তোমাদেরটার মধ্যে নাই, তোমাদের তো পুরোটাই আছে। In some syllabus they'll just say that AC outputটা হচ্ছে half হবে সব সময়, and they don't give any reason behind that, and they'll just say just continue that way. তোমাদের syllabus they actually show you a reason, because আমরা যখন পাওয়ারটা বের করতেছি, আমরা কি দিয়ে পাওয়ারটা বের করতেছি? RMS value দিয়ে। Okay, and এটা actually RMS হচ্ছে better হবে। So this is VRMS into IRMS. So yeah, this is your power calculation problem. So আমি আরেকবার পুরো জিনিসটা রিক্যাপ করি, এটা শুনো। It's a very small topic, okay? You have an AC supply. AC supply এর জন্য তোমার ল্যাম্পের ভিতরে power dissipate হচ্ছে। Somebody wanted to find the power. পাওয়ারটা বের করতে গিয়ে the person came across a problem. কি? যে তোমার তো খালি চেঞ্জ হচ্ছে। So যদি চেঞ্জ হয়ে থাকে, you need to take an average, right? Now if you take the true average, তাহলে কি আসে? Zero, which means তোমাকে দেখাবে যে তোমার ডিভাইসে কাজই করবে না, zero output, right? That's not true. But somebody thought, okay, I'll just take the peak values, which is also a problem, because peak now you're assuming that the voltage is always that value, current is always that value. That's straightforward what of the value, overestimation. So then the question arises that what should we do? So we need to find this true mean. True mean টা হচ্ছে RMS বলা হয়। এই true mean টা বের করার নিয়ম হচ্ছে তোমার V max কে কি দিয়ে ডিভাইড করবা? √2. And once you do V max by √2, যে ভ্যালুটা পাও এখানে, that is the actual mean here. And এটা মানে কি? You have converted this AC supply to a watt supply, a DC supply. Now you know a voltage that is the AC supply's watt version, DC version, right? And now you can do your math using every DC equation you have here. So একটা তোমাদেরকে example দেখাই, তোমাদের বাসাতে কি হচ্ছে? So your house, বাংলাদেশের সব বাসায় actually has an AC supply, and the AC supply is কত ভোল্ট কি জানো তোমরা? Yeah, 220, 240 to fluctuate. Okay, so 240 volts and 50 hertz. That's the voltage in your house. Let's say তুমি তোমার বাসার ভোল্টেজটাকে রিপ্লেস করে এসি থেকে ডিসি তে নিতে চাও। এখন তুমি 240 ভোল্ট ডিসি ইউজ করো, দেখো তোমার বাসার অ্যাপ্লায়েন্স কাজ করতেছে না, because this 240 is your watt value, peak value. So তোমাকে এটাকে কনভার্ট করতে হবে to equivalent watt value, DC value, which is not going to be a voltage of just 240. It's going to be actually watt. 240 divided by √2. কি একটু চেক করে দেখো কত আসে? Yeah, 169.71 volt. Yes, now if I take this whole setup of this house, take the AC supply out, connect like a massive battery of 169.71 volts, right? You wouldn't notice any difference. They were shop একদম same চলতেছে, because the AC and the DC provide what power to you? Same power, equivalent power. তার জন্য you wouldn't notice. You get my point? অনেকে যেটা mistake করে is that they'll replace this with a 240 volt watt supply, DC supply, and everything fries. Cannot, because that's too much for the supply. It's like too much voltage. Power and overheat with it. If you're giving 240 continuously, it can take 240 in cycles, right? But continuous 240 দিলে কি হয়ে যায়? Overheat করে. So একটু কমায় দিতে হয়, and কমায় কত দিতে হবে? 169.7. Because if you look here, definitely there are times when the voltage is 240, but there are plenty of times when the voltage is not what? 240. So what is the true average here? 169.71. Okay, and that's how your house will appear just working the same way. Okay, so yeah, this is the thing. এখানে যা কপি করতে চাই করে নাও, আমি একটা নোট দিব, and আজকে আমরা rectification and smoothing টা করব. Okay. Wait, there's a note here, note copy, I think better. Yeah, this. Just a niche DC equivalent to an AC supply. What does it mean, right? Just you can copy that and the conversions and everything. It's a page. A topic 21 or আগের page থেকে করতে পারো, where the graph is provided. You can add it there. But more importantly, if you have any questions, let me know. Okay, মানে কোনো clarification লাগলে আমাকে জানাও. Very good. Still, not a bad idea, but the it's like a Saturday, 4th. Yeah. Our aim is to finish quantum physics and nuclear before the break. So the then I'll probably take these extended classes every day in every class. This nuclear physics কিন্তু শেষ করতেই হবে. তারপরে medical physics, it's not a problem. Not a problem, and it can be managed. So, but quantum and nuclear, like almost every year, আসে questions. Tuesday morning. আমি তো লাস্ট টাইম বলছিলাম টিউসডে মর্নিং ক্লাস, তোমরা তো সব বলে আসবে, আসো নাই তো। হ্যাঁ, লিঙ্কডইন there are other people out there ওদের থেকে কাজ করছে, মানে ও আচ্ছা। Great. Tuesday morning. নিতে পারি, প্রবলেম নেই। হ্যাঁ, কিন্তু গুগল ক্লাসরুমে নাই। Why are you talking about classroom? Your email has been added, but accept on it. হ্যাঁ, আজকে এই যে জিনিসটা করবো পুরোটাই রেকর্ড করবো। ইটস ওয়ান ভেরি লার্জ এক্সপ্লেনেশন, সো একসাথে করে ক্লিয়ার। ওকে, সো একটু দেখি আমরা what did the syllabus actually want from us, ওইটা আগে দেখে আসি। So according to the syllabus, we are supposed to, the last day baki chilo, distinguish between RMS and peak value, and recall that IRMS is I naught by root 2, VRMS is V naught by root 2. And also recall that the mean power is half the maximum power of a supply. Do you understand what that means? The mean jeta ashe ota like actual power ki hoy, মানে actual peak value ki ashe half. ওই যেটা একটু আগে দেখলাম, I'll write it here, it's actually important. So এই মাত্রই করছি তাও দেখাই। We know that power equals to what? Just V peak into I peak, যেটা আমরা anticipate করছিলাম। But the power average is actually what? V peak into I peak divided by 2. কোথা থেকে আসে এই 2টা? It was basically a multiplication of VRMS into IRMS, which is V peak by root 2 into I peak by root 2. Maybe a derivation দিতে পারে, আচ্ছা। So that's the reason why the power is exactly half. And yeah, so that's the AC supply. I think একটু বুঝা উচিত, it's not that complicated, but এই ফরম্যাটটা মনে রাখতে হবে। Okay, also this is your omega, which is the supply frequency উপরে based. All right, let's move on. আজকে যেটা করবো, ওরা একটা সেপারেট এটা দিয়ে দিচ্ছে, মানে heading for it, which means it's important. It says rectification and smoothing. So we're going to do this all at once. কি করবো একটু বলি তোমাদেরকে। So এখানে অনেক কিছু বলছে, distinguish, half wave, full wave, explain diode কি করে, explain diodes হচ্ছে rectify, bridge করে, তারপর হচ্ছে এটা basically the summary of it, তাহলে তোমাদের জন্য easier হবে to understand what I'm going to do today is I'm going to take an AC supply, okay, just proper pure AC supply, and we need to convert this into a full constant DC supply, not through math, literally. When I want to take an AC supply and make it into a DC supply. So আমাদের কেন দরকার এটা একটু explain করি। This is arguably, right, the most important practical use of any electronic things that you have learned so far. The reason behind that is আমাদের বাসায় যে power আসে, and until 90s, right, it was fine because we used to work on filament lamp. Filament lamp current এদিকে গেলে ওদিকে গেলে doesn't really matter. If you remember from your O level, filament lamp graph এরকম ছিল, এই যে দুই দিকেই same. So it was fine, right? But then 2010 এর দিকে we started using what in our homes? LEDs. And LED stands for light emitting diode, right? And diode যদি ইউজ করো তাহলে প্রবলেমটা কি, তোমার সাপ্লাই যদি একটা দাও AC, diode will block one of the sides and allow the other side, which is fine. But the problem is that you're paying for the full, but you're using how much of it? Half, right? So eventually we understood that we need to convert to what? DC supply. Where else do you need DC? So this goes back 1950s, fans. So fans, DC motor, literally. So any motor out there will have to run on what supply? DC. And not only just DC, it has to be perfectly smooth, flat DC. Okay, because if there's any fluctuation in your DC supply, right, what will happen to the fan speed? It will fluctuate as well. So what kind of a supply do you need? Proper flat one, right? So what we need to do here is make this AC supply into a proper flat DC supply. And right now, 2025, every appliance that we use uses what? DC. So you think of computing. Computers can runs on silicon chips and processors. Processors can run on AC. On AC supply, there are computing chico, there are states in it, highs and lows, ones and zeros. So when you AC continuously flip with it. So you need to ensure that the states are held. High or low and that can only happen if you use a water supply, DC supply. So if you have a PC, you'll know that PC with like a power supply again, a separate box. It's called a power supply. But power supply is actually a what? Converter. It takes your AC, converts into what? DC, right? There is a thing as well. The fan you'll hear them say that capacitor capacitor fan speed fluctuate, make sound and whatnot. Basically, it's not a water supply that's receiving anymore. DC supply, it's fluctuated, right? So DC to convert kora is at this moment the most important thing that we have, because otherwise none of the appliances would work. TVs are all LEDs, right? Computers are all computing. So whatever you think, and that's the reason why this is the century of your adapters. Everywhere you go, you have to have one of these. 20 years back, how did things work? Just plug it in. Think of TVs out there. Old TVs, right? They just directly TV lagai diba power supply te mane wall er moddhe kono problem nai. Ekhon ki dekhba TV সাথে একটা brick আসে, laptop এর একটা brick থাকে না, বা দেখবা TV এর মধ্যে একটা brick আছে, তোমার whatever appliance you buy, right, laptops or TVs, you see that there's this extra thing out there. ওই extra brick is actually a what? A converter, okay? It's not only a converter, it's actually a converter and a transformer. Our voltage will change. So when I'm charging my phone, right, my phone uses 6 volts, but Basha supply 220 volts. So I need to take the 220 volts to what volt? 6 volt, right? That can only be done using a what? Transformer. A what transformer? Step down. So if you ever break one of these, right, you'll find capacitors, you'll find coils, you'll find a core iron. There's a transformer inside this, and okay, so that's what we're gonna do. So practically you probably come across this the most in your daily life, right? So এখন যেটা করব, we'll take a AC supply and convert it to DC supply. Because আগের আপনার সব AC তে কাজ করতো, হ্যাঁ, like TVs যেগুলো ছিল ওগুলো CRT TV ছিল, তারপর refrigerators, আজকাল smart refrigerator আছে পর আবার DC তে নিয়ে যেতে হচ্ছে because they have like processor in them for whatever reason. But yeah, the thing is that they tell you what recipes can be made from what you have in your fridge. Yeah. So anyway, the point is that it's called IoT, Internet of Things. Like everything is connected through internet, right? So you need DC supply, right? So we'll start from ekdom scratch. It's at single go te bujhabo tomaderke. So attention though, okay? So we're gonna convert an AC supply to a DC supply. So AC to DC. So first step let's introduce our AC supply there. যেটাকে আমরা convert করব. So our AC supply that we're going to convert is like this. এটা হচ্ছে 2 cycles draw করব for convenience purpose.
Recording in progress.
Right. So what we're going to do right now is this is my AC supply, and voltage, current, it doesn't really matter. I mean, current tomader voltage problem because current is driven by voltage. Okay, so that is no issue out there. So that's current. This is time, seconds. So we'll start with a visit to our O levels. O levels say we knew that if you have a circuit, right, with an AC supply, it Cambridge student is that you have an AC supply and output dekhte hobe. So if anyone wants to see the output of an AC supply, what would you connect your AC supply to? Yes, cathode ray oscilloscope. Okay, so a cathode ray oscilloscope is a perfect device to see the output of an AC supply. So I'm the AC supply ta CRO এর সাথে connect kori, right? What will I see? I'll see this graph. Okay, I'll see that screen and graph যাচ্ছে একটা. So that is where the AC supply comes from. এখন what we need to do here is set this up and একটা component আমরা try করব. So if I place a CRO here, cathode ray oscilloscope, CRO, the output is going to look like this. Do you agree? Okay, so I'll just take this and put it on the side here to show that the CRO is going to give you this right now. Okay, now we'll do one modification. Modification, we will take the same circuit, right? Everything same. And this time, we will place a component in the circuit, which you have learned in your O-levels. Ota hocche a semiconducting diode, just a diode boleo chole. So, tomar diode ta hocche ekhane place kortesi ami, like this. So if I place my diode here, diode is a electrical component that provides conditional passage of current. All right? So can you tell me the presence of a diode will result in what output here? Output. Yes, so the diode will either make the negative values go away or make the positive values go away. It's actually subjective, right? So let's say so this one is generated by the addition of a diode. So if you add addition of a diode, and the addition of a diode does something. A shapeter naamta ki recall korte paro kyo? There's a name for this graph. So first of all, let's get to the basics. Is it AC or DC? Okay, graph is it AC or DC? Yes, DC. DC cannot because it is khali key value, positive. It's a DC, right? But it's a what DC? Fluctuate in DC, change in DC, not a constant DC, right? So it is DC bola hoy. So addition of a diode, you get a DC supply. Change in DC. Can you tell me what's the name of this thing? The graph ka naam ase. It was there in your O-levels. I know it's pretty long back, but it was called half-wave rectification. So rectification word ta use kora hoy to make your AC to DC. Have we converted all the AC to DC or only half of it? Half of it. Baki je half gulo chilo, what did we do? Just, throw them out, right? That's not the right way going forward. But this is not bad. It once upon a time it use korto. Etake bola hoy half wave rectification. So half wave rectification is the process by which you can convert your AC into a change in DC. Okay, and then half the cycle is available. Are you clear about this? So the other half is gone, right? And this half is there. What's wrong in this? Use for the fan, key problem. Yeah, the fan will have like a fluctuating motion, right? If I use this in a lamp, what's the problem? On and off. It's on and off right now as well. So, the key problem. More power use. Loss of current. Where would current go? The gaps are larger. Yeah. So one problem which you wouldn't really know, but is that there's a lot of gap, right? Like the morning border part current pass. So if you're looking at the lamp, in theory, it should appear to flicker. But problem is our eyes are lazy. 10 like anything that's more than 10 hertz, right? Our brain meshes it together. So you wouldn't know. But that's not the main problem. What's the main problem? Yes, you just by this, on the first step, right? What did you do? Just get rid of half of the power. Cycle, so you paid for it, right? But even if your appliance hasn't taken anything right from the beginning, how much power do you have? Half of it. Baki half wasted na. So if I let's say pay my bill and আমি হচ্ছে বাসার সবকিছু এটাতে চালালাম, আমি bill pay করব যে output পাবো কোনো efficiency include না করলেই how much am I getting at maximum? 50%. তারপরে তো appliance কিছু waste করবে. So eventually it's going to be a very inefficient process. Okay, so this one is fine. It's a DC supply. It's a fluctuating DC supply. Lamp use করতে পারবো, but it is very inefficient. Half the power just disappeared, right? So if only we could have all the power. So এটা করার জন্য we go to the next step. So আমাদের aim right now is to get a graph that looks like what? বলতে পারবা কি চাচ্ছি আমরা? Yeah, we want these to come back. এটা is actually pretty good. Why? Because I'm getting all the power I paid for, and also a stoppage gulo oto boro na, right? Also, it's a DC supply. How do we get here? So data করার জন্য we have a special circuit. So I'm going to introduce that circuit to you. To achieve this, we use something called a bridge rectifier. So bridge rectifier হচ্ছে a circuit that converts your AC to change in DC, but converts which cycle? All cycles. Okay, so এটা কেমনে করতে হয় দেখো, আমি ডায়াগ্রামটা ড্র করা দেখাচ্ছি, because তোমাদের ডায়াগ্রাম ড্র করতে হয়। So স্ক্রিনে দেখো কি করতে হবে। So you first create a circuit like this. Sometimes ওরা এটা দিয়ে দেয়, ওরা just diode গুলো ড্র করতে বলে। Right, so এভাবে আমরা ড্র করি। এটার যেমন হচ্ছে like a name used to be the diamond circuit, but yeah, এখন just bridge rectifier ডাকি। So we'll take a structure like this. These are wires, by the way, সব তার। আচ্ছা, আর এই পয়েন্টস গুলো, these are all junction. You know what junctions are? Junctions are places where current can divide. Okay, so আমি can এটা mention করতেছি out of nowhere, আমি explain করবো একটু পরে। Cambridge একটা ঝামেলা করে। So these are junctions out there. And what we're going to do is we'll place our component in this location. So whatever component that we want to have our supply across, right? এটাকে এই জায়গায় place করব. So right, so component কেন ওই জায়গায় place করব আমি বুঝাচ্ছি তোমাদেরকে। So there you go, এই মাঝখানে, and then এখান থেকে হচ্ছে আরটা তার দিয়ে হচ্ছে এই জায়গায় place করব। So that is going to be our supply. Is it clear? Okay, so you have the junction at the bottom, a niche, and everything it's here. এখন we need to turn on the circuit. A circuit যদি on করি, can you tell me what will happen? Let's say I turn on the circuit here, right? কি হবে? Current will flow. আচ্ছা, কোন দিকে? No, in the first cycle, it's a plus, it's a minus, right? Which would current? Plus to minus, right? So এদিক দিয়ে যাবে, এখানে যাওয়ার পর কই যাবে? দুই দিকে, right? তারপর কই যাবে? নিচে, তারপর কই যাবে? ব্যাক করে দিকে যাবে। এটা হচ্ছে শর্ট সার্কিট। কেন? বিকজ এই মাঝখানের ব্রাঞ্চে কারেন্ট যেতেই যাবে না। Why would the current even take that path? Do you know what short circuit is? Short circuit is when the current takes the what path? The shortest path out there. So এখানে shortest path কোনটা হবে? Just এভাবে করে চলে যাবে, right? এইখানে তো যাওয়ারই কোনো দরকার নাই। So এটা short circuit হয়ে গেছে। And then this is not the right way of obviously doing it. So আমরা যেটা করব is we're going to force the current to take the right path. Right pathটা কি হবে? To pass through the diode, right? How do I ensure that? So to ensure করার জন্য diode না, component, sorry. What I'll do here is I'll place a diode like this. So diode গুলো কেমনে draw করতে হয় একটু শিখাই তোমাদেরকে। My draw in the sense how do you align them? Orientation কি হবে? So this is one of the diodes, right? The rule is two of these diodes, a branchও থাকবে, এখানেও থাকবে, এখানেও থাকবে, এখানেও থাকবে. There'll be 4 diodes here, okay, by the way. So the diodes on opposite parallel branches need to face the same way. That's one trick. আচ্ছা, so এটা এখানে রাখলাম আর এটা এখানে রাখলাম, and the diodes in the other branches need to face the other way, and they need to be what to each other as well, parallel. So they say দুইটা same face করে, দুইটা same face করে. If you can do that, it's it. That's how the circuit is going to work. Okay, now I'm going to show you how it works. কেন হচ্ছে আমার কারেন্টটা বারবার same face follow করবে, মানে same path follow করবে। So see this, we're going to label this point A, এখানে কারেন্ট কি করে enter করে, and we're labeling this point B, এখানে কারেন্ট লিভ করে। follow the current, আচ্ছা কেয়ারফুলি একটু শুনো কি করতেছি আমি এখানে, বিকজ তোমরা এক্সামে ড্র করতে হয়, অলসো এক্সপ্লেইন করতে হয়, বাট আগে বুঝি। So let's say this is plus and this is minus. Let's follow the current path here. Current কোন দিকে যাবে? So এটা briefly the other day মনে হয় বুঝাইছিলাম, but আবার দেখাচ্ছি। The current will go from higher potential to lower potential, right? So I will follow my current here. The current will go from here, এভাবে, and the current will go there to this junction. As it reaches this junction, there are two paths here, right? Left and right. Which one will it take? Left, because what's the term? The diode on the left is forward bias. Okay, forward bias is the term. Forward bias means a diode is in the orientation that allows what to pass through current. Okay, and then it comes to this junction here, and it can now only go which way? To the right. So where does it enter? Where does it leave? B. Keep that in mind. So let's say you're the component, right? So A side to A, side to B. You'll see current entering from A and leaving from where? B. Now the current comes to this junction here. Now there are two paths here, up and down. Which way does the current flow? Yeah, because can you observe it? Current doesn't flow back to higher potential, right? If you think of this like a pipe in your house, পানি পড়তেছে পাইপের ভিতর দিয়ে একটা জায়গায় সে পাইপটা উপরে চলে গেছে পাইপটা নিচে চলে গেছে, and there's water flowing. Does the water go back up to the roof? No, right? Where does the water keep going? Down. That's how potential works, right? So এটা potentialটা এখানে আসবে, এখানে আসার পর again it won't go back up. It'll go this way and it'll go there. And this time it's one cycle, right? যেখানে এটা plus ছিল, এটা minus ছিল. Let's see what happens in the reverse cycle. Okay, so reverse এটা হবে হচ্ছে minus, এটা কি হবে? Plus. Let's follow the current now. So if I look at the current flow here, the current is going to go this way. It's going to go that way. And এখানে আসার পরে where does it go? Left or right? Left. And এখানে আসার পরে where does it go? And once again, it entered through which point? And left to which point? So if you are the component once again, right, you'd see the current once again in the second cycle come from where? A, and leave from where? B, right? And it then comes to this point, and then it goes back up here, and then it goes back there, and then comes back here, which means every cycle, the current keeps entering from which side? A, and leave from where? B. And that means all the cycles are in what direction? Same direction, right? And once you place a CR wave across this component, you'll see the output is this. Okay, so this is what is known as a bridge rectifier. A bridge can bole je মাজখানে যে জায়গাটা, that's the bridge. Current goes through the bridge. Okay, so আমরা হচ্ছে add করি. So that was addition of a diode. And what do we get with the addition of a bridge rectifier? Bridge. So yeah, with the addition of a bridge rectifier, we do get an AC supply to DC supply, but once again, it's a what DC? Constant or changing? Changing DC, but with one advantage, more efficient, because you are getting back all the cycles. And there's a name for this. It actually half-wave rectification. What would you call this? Right, this is called full wave rectification. Right, so we have gone from that to this right now. Next on the task to make it what? A straight line. Okay, so we'll just start in a few minutes, but before that, the only question that I want to follow. Question থাকলে বলতে পারো আমাকে। Interesting. No, this is not going to be. Oh no, you can. It'll be the same. So the RMS of this is going to be V peak by √2, because what we did there earlier, right? We just made the lower part come to the top, right? Here it's already at the top, so the RMS doesn't really have any difference here. So in the previous one, we squared the positive ones, we squared the negative ones. Here we're squaring the positive ones, and the others are already positive. So eventually the outcome is the same.